Hello dear learners, welcome back to my channel. So today we are going to derive the equation for electric field along the equatorial line of a dipole. So here in the diagram you can see that we have an electric dipole AB. Alright, so this dipole has minus Q charge at A and plus Q charge at B. And these two charges, minus Q and plus Q, they are separated by a distance of twice A, which is also called as the dipole length. From the center O up to the point A and up to the point B, the distance will be A itself. So A plus A will give us twice A. So we have a dipole AB having charges minus Q at A plus Q at B and dipole length twice A. Now here we are trying to find out the electric field at any point along the equatorial line of the dipole. So what is an equatorial line? An equatorial line is a line which bisects the dipole. So here in the diagram you can see we have drawn this line which passes through the center O of the dipole. So this line bisects the dipole into two halves. So along this equatorial line at any point we are supposed to find out the electric field. So we have taken this point as P, which is at a distance of R from the center O of the dipole. So we will be finding out the electric field at this point P, which is along the equatorial line of this dipole because of this dipole. So first what we will do is we will find out the electric field at P separately due to minus Q charge at A and plus Q charge at B, and then we will find out the total. Alright, so we will be using this equation here, 1 by 4 pi epsilon naught Q divided by R square. So we will be using this expression to find out the electric field at P due to minus Q charge and electric field at P due to plus Q charge. So let's start the derivation. So electric field at point P due to minus Q charge at A can be written as EA equals to 1 by 4 pi epsilon naught Q divided by, now the distance between the 2 points is AP, so we will write it as AP square, and let's join this 2 points. So we have found out electric field at P due to minus Q charge at A. Using this relation we have EA equals to 1 by 4 pi epsilon naught Q divided by AP square. And since we have a minus Q charge at A, the direction of this electric field EA will be along PA. Since for a negative charge the electric field is always towards. So we can write this EA directed from P to A in this way. So this is EA vector, that is electric field at point P due to minus Q charge at A. Now let us find out the value of AP square from the diagram. So this equation further can be written as EA equals to 1 by 4 pi epsilon naught Q divided by, now let's find out the value of AP square. So for that what we will do is take this triangle AOP. So AOP is a right angle triangle where we can apply the Pythagoras theorem, which is hypotenuse square equals to perpendicular square plus base square. So in this triangle AOP, so this is a right angle triangle as I said. So in this right angle triangle we are applying the Pythagoras theorem. So in this triangle AP, which is the longest side, will be the hypotenuse. So we have AP square. Perpendicular will be OP. So we have OP square here, and OA will be the base. So we have OB square. Now if you look at the diagram, we have the value for OP and OB. So let's put the value of OP and OB here. From the diagram, the value of OP is our R. So this becomes R square. And the value of OB, this is not OB, this is OA. And the value of OA is our A. So the value of AP square, we will get it as R square plus A square. So this value we are going to replace it here. So this will become R square plus A square. So let this be our equation number 1. So this equation tells us the electric field at P due to minus Q charge at T. Now similarly, we'll find out electric field at point P due to plus Q charge at B. So that electric field we can write it as EB 1 by 4 pi epsilon naught Q divided by, now the distance between these 2 points is PB, yeah, or you can write BP. So BP square, and the direction of this will be along BP, since we have a positive charge here, and for a positive charge the electric field is always directed away. So let's join these 2 points as well and extend this line a little bit. So this will be the direction of our electric field EB. Alright, since we have a positive charge here, electric field at point P will be directed away. For this, electric field will be directed towards. For negative it is towards, for positive it is away. Now let us again find the value of BP square from the diagram. So we can further write this equation as EB equals to 1 by 4 pi epsilon naught Q divided by, again in order to find the value of BP square, let's take the triangle BOP. This is again a right angle triangle, so BOP. So applying Pythagoras theorem, which is hypotenuse square equals to perpendicular square plus base square. Hypotenuse now is BP, so BP square. Perpendicular is OP, so OP square, and base is OB, so we can write it as OB square. Right? So now put the values, we will get BP square is equals to OP is R again, so R square. BOB is our A, so this becomes A square. So using this triangle BOP, we get the value of BP square as R square plus A square. So we'll replace this value here. So this equation becomes R square plus A square here. So let this be equation number 2. So we have found out electric field at P due to minus Q charge and due to plus Q charge. Now we have to find the net electric field at the point P. Now in order to find the net electric field at point P, we cannot directly add or subtract. Why? Simply because these two vectors are not along the same straight line. So here we will use the concept of vector addition. In class 11, we have parallelogram law of vector addition, which says that if two sides of a parallelogram acting at a point represents the two vectors both in magnitude and direction, then its resultant is given by its diagonal. For example, let's say we have this two vectors, vector A and vector B, represented by the two sides of this parallelogram here, and they are acting at a point, means they have the common vertex. Then the resultant of these two vectors will be given by its diagonal. So this diagonal will give the resultant vector R, which is A plus B vector. So we will use this concept here as well. Okay. So for that, what we will do is, if we join this, then we can form a parallelogram here. So we can form a parallelogram here. So EA is given by this side and EB is given by this side, and they have a common vertex at the point P. So the resultant of these two vectors will be given by the diagonal. So we will draw the diagonal here. So this, let's say this is point N. So this diagonal PN will give us the resultant electric field, which is E, or the total electric field at the point P. Right? So let's say this is angle theta, then this angle will also be theta, alternate angles, and if this is angle theta, this will be theta itself, and this will be theta, because these two are corresponding angles. So So let's now find out the value of this resultant field E. So for that we will use another formula from class 11 vectors, which is r square is equals to a square plus b square plus 2ab cos of theta. And here theta is the angle between the two vectors, that is a vector and b vector. So we will apply this formula to find out the magnitude of this resultant field E. So let's do that. So our resultant electric field is E. So instead of r square we will write E square equals to the first vector, instead of a we have EA, so we will write EA whole square plus the second vector b is our EB, so we will write it as EB square plus twice EA EB. And here you have to be careful. As I said, this angle theta is the angle between the two vectors, that is vector A and vector B in this case. Here we have the two vectors, EA vector and EB vector. Now the angle between EA vector and EB vector is this one. So this will be theta plus theta. So this angle between EA vector and EB vector will be equal to twice of theta. So here you have to be careful. It's not cos of theta, it will be cos twice of theta, because it is the angle between the two vectors, that is EA vector and EB vector. So using this formula, we have written the magnitude for the resultant electric field. And also here you can say the direction, since the direction is given by the diagonal of this parallelogram and it is directed along PN in the diagram. So this resultant electric field will be directed along PN. So let's expand this equation further. So for that, what we will do is look at equation number 1 and equation number 2. So equation number 1, E equals to 1 by 4 pi epsilon naught Q divided by R square plus A square. Equation 2, EB equals to 1 by 4 pi epsilon naught Q divided by R square plus A square. Which means these two equations are equal, which is EA equals to EB. So since EA is equals to EB, or we can say EB is equals to EA, we will replace EA instead of EB in this equation. So we can write E square is equals to EA square. Instead of EB, we will write EA. Here also, instead of EB, we will write EA cos of 2 theta. Here you can give the reason, since EA is equals to EB. The two values are equal, so we can replace EA instead of EB or EB instead of EA. So here we have replaced EA instead of EB in both the cases. So let's further expand this. So here, if you add EA square and EA square, this becomes twice EA square plus, here if you multiply EA and EA, this also gives us EA square. So we have added this to EA square plus EA square, so we got twice EA square. Here we have multiplied EA and EA, we got EA square here. Now after that, we can take out the common. So the common term here is twice EA square. So once you take out twice EA square common, here we will have 1 and here we will have cos of twice theta. So now here 1 plus cos 2 theta, we can replace it with another formula from trigonometry. Those who have maths, they know the formula. Those who don't have maths, you have to learn this formula. So here we can write this as 2 cos square theta. Now how did we get this? So we have the formula for cos of 2 theta, which is 2 cos of square theta minus 1. So if you bring 1 to the left hand side, it becomes plus 1. So 1 plus cos 2 theta can be written as 2 cos square theta. So we are using this formula here. be careful while writing cos of 2 theta and cos square theta. These are two different terms, right? So 1 plus cos 2 theta can be replaced with 2 cos square theta here. Alright. Now if you multiply, you will get twice into twice will become 4. We have a square and cos square theta. Now if you take square to the other side, it becomes square root. So we have square root of 4 ea square cos square theta. So square root of 4 is 2 and ea square is ea. Cos square theta simply becomes cos of theta. So square root of 4 is 2, ea square is ea, cos square theta becomes cos theta. Now from equation 1, we can replace the value of ea here. So twice the value of ea was 1 by 4 pi epsilon naught q divided by r square plus a square into, we have this term cos of theta. Here you can write using equation 1. So from equation number 1, we have replaced the value of ea, which is 1 by 4 pi epsilon naught q divided by r square plus a square. So let this be our equation number 3. So now what we need to do is we need to find the value of this cos theta. So let's find the value of this cos theta and put it here. So for that, what we will do is we will take the triangle OAP. So if you take this triangle OAP and if you find cos of theta here, we know cos is curly brown hair, that is based upon hypotenuse. So in this triangle, the base is OA and hypotenuse is the longest side, so this is AP here. Now from the diagram, the value of OA is nothing but A, and the value of AP, we will get it from here. In equation number 1, we have written AP square is equals to R square plus A square. So if you take square to the other side, then we'll get AP is equals to R square plus A square under root, which can be also written as R square plus A square to the power of half. Square root can be written as power half. So the value of AP, we will replace it as R square plus A square to the power half. Let this be equation number 4. So I hope you have understood why AP is R square plus A square to the power half. So since we have obtained the value of cos theta, let's replace the value here. So putting equation 4 in equation 3, we have, so let's replace this value. So we will get E is equals to, we have twice into 1 by 4 pi epsilon naught. We have Q divided by R square plus A square, and then instead of cos theta, we'll replace the value as A divided by R square plus A square to the power half. Alright, so we have just replaced the value of cos theta here. We can further write this equation as 1 by 4 pi epsilon naught. If you look at the numerator, then we have Q into twice A divided by, we have R square plus A square. If you look at the denominator here, this is R square plus A square to the power 1 multiplied R square plus A square to the power half. So when the base is same, power is always added. For example, if you have x to the power 1 into x to the power half, then since the base is same, power needs to be added. So this can be written as 1 plus half, which becomes x to the power 3 by 2. So similarly here, we have R square plus A square to the power 1 into R square plus A square to the power half. So since the base is same, you need to add the power. So you will get here 3 by 2. I hope this is clear to you. So Now here in the numerator we have this product Q into twice A, and this product Q into twice A is nothing but it is the dipole moment. So we'll replace it with P divided by, denominator becomes R square plus A square to the power 3 by 2. Let this be equation number 5, and here we have used P is equals to Q into twice A, which is the electric dipole moment. So here instead of Q into twice A, we have written P. So this is one equation for electric field along the equatorial line of the dipole. Now, if the dipole is short, which means that if this distance R becomes much greater than A, if the dipole becomes short, then the value of A will decrease. So then what happens to the equation? So let's see that. So we are saying now for a short dipole, R is much greater than A, and under this condition R square plus A square can be written nearly equal to R square. So if you replace this value here, so let's put this in equation 5. So what we will get? E is equals to 1 by 4 pi epsilon naught P divided by R square plus A square can be simply written as R square only. So this becomes power 3 by 2. So here this 2 and 2 can be cancelled. So our final equation, we can write it as E is equals to 1 by 4 pi epsilon naught P divided by R cube. So this is the final equation for electric field at any point P which is along the equatorial line of the dipole. So this is also one important derivation from the first chapter, that is electrostatics. So you can go through the derivation. If you have not gone through the first derivation, which is electric field along the axial line, you can check that video. So that's all for today, and please do like, share and subscribe my channel, and please do give suggestions. Thank you everyone.